Welcome to the DIY Honda Garage channel. The DTC P15C7 indicates a specific issue with the brake booster pressure sensor A in the Honda Civic 2022 and later models. This error suggests that the voltage output from the brake booster pressure sensor is higher than the acceptable limits when the vehicle is moving above a specified speed and is operating under stable conditions of negative pressure. The engine control unit, known as the Powertrain Control Module (PCM), detects this abnormality and logs the diagnostic trouble code (DTC) for further investigation. The brake booster pressure sensor plays a crucial role in assisting the driver in applying brake force efficiently. If it is not functioning correctly, it can affect braking performance and vehicle safety. The sensor is located within the brake booster assembly, interacting closely with the vacuum lines to ensure optimal brake performance. Identifying this fault is critical to maintaining vehicle safety and performance. The brake booster pressure sensor, A, is a vital component located in the brake booster assembly. Its role is to monitor the brake booster's pressure, supplying data to the Powertrain Control Module, PCM. This allows the PCM to determine whether the brake assist function is operating within normal parameters. If the sensor detects a higher than normal voltage output while the vehicle exceeds a certain speed under stable negative pressure conditions, it identifies it as a fault, resulting in the DTC P15C7 being stored. The brake booster system relies on negative pressure generated by the intake manifold. Thus, any issues within this pressure system can directly correlate with braking efficiency and safety. Additionally, the PCM uses this information to make adjustments to ensure optimal performance, and any discrepancies can lead to engaging vehicle safety protocols. The possible causes of DTC P15C7 primarily include a malfunctioning brake booster pressure sensor, A, issues with the brake booster vacuum hose, or electrical connectivity problems within the sensor circuit. A faulty brake booster pressure sensor might provide inaccurate readings, thus leading to incorrect adjustments by the PCM. If the brake booster vacuum hose suffers from leaks or damage, it could result in abnormal pressure levels, which would also cause the sensor to output erroneous values. Any disruptions in electrical connectivity, such as corroded connectors or damaged wiring, can further exacerbate the situation by failing to transmit accurate signals to the PCM. Identifying the precise cause is crucial in ensuring the brake system functions effectively, maintaining safety. Understanding and troubleshooting these potential causes can lead to a comprehensive resolution of the DTC. When the DTC P15C7 is triggered, several symptoms may manifest. Commonly, the vehicle may display an illuminated warning light on the dashboard, indicating a fault in the brake system. This is an immediate visual cue for the driver to seek diagnosis and repair. Additionally, there may be noticeable reductions in braking performance, such as increased stopping distances or a feeling of unsatisfactory brake response, which can significantly compromise driver safety. Unusual feedback from the brake pedal, such as a spongy feel or lack of resistance, is another symptom that may arise, often linked to issues with the brake booster system or its components. These symptoms collectively serve as critical warning signs that demand immediate attention to ensure the safe operation of the vehicle. To begin resolving the DTC P15C7, the first step involves starting the engine to establish baseline operational conditions. Subsequently, the vehicle should be test-driven, ensuring it reaches and maintains a speed of at least 19 miles per hour, 30 kilometers per hour, for a continuous duration of at least 10 seconds. It is crucial that the accelerator pedal is released during this test to provide an accurate representation of how the brake booster pressure sensor behaves. This test is not conducted on a lift, as real-world driving conditions can significantly affect the performance of the braking system. By doing this, the PCM evaluates the brake booster pressure sensor's output in a dynamic scenario, which is essential for diagnosing potential faults accurately. Safe test driving practices must be observed throughout this procedure. In this troubleshooting step, the Honda Diagnostics System, HDS, is utilized to assess the brake booster pressure sensor A's measurements. First, the values from the sensor are adjusted using accelerator pedal operation to achieve a minimum target pressure of 66.7 kilopascals, 500 millimeters of mercury, 19.7 inches of Hagging. Following this, the vehicle should be turned off for 30 seconds, allowing the system to reset and stabilize. After the waiting period, the vehicle is started again, and the HDS data must be reviewed to confirm the brake booster pressure sensor A's correct values. The normal criteria stipulate that the HDS should not indicate changes greater than 2.7 kilopascals, 20 millimeters of mercury, or 0.8 inches of Hagging. If the reading exceeds this threshold, it indicates an abnormality in the brake booster system, necessitating further inspection. This step focuses on evaluating the functionality of the brake booster vacuum line. Start by turning the vehicle off, lock mode. It is necessary to deplete the vacuum in the brake booster. This is achieved by pressing the brake pedal several times until the pedal feels firm. Next, press the brake pedal firmly and hold it down. Then proceed to start the engine. In a properly functioning system, the brake pedal should sink slightly under your foot, indicating active engagement of the brake booster. If the brake pedal does not respond in this manner, or if it feels unusually stiff, it may signal a problem within the brake booster vacuum line or other related components. Properly executing this step is crucial for assessing the integrity of the braking assistance system. During this step, the engine must be running to assess the vacuum hose's integrity between the intake manifold and the check valve. The technician must examine the vacuum line for any signs of leakage, which can undermine the effectiveness of the brake booster system. A vacuum leak can occur due to frayed hoses, loose connections, or cracked components. Using visual inspection and potentially employing diagnostic tools to identify leaks is critical in this phase. Normal functionality dictates that there be no detectable leakage during this inspection. If any issues are noted, such as hissing noises or a collapsing hose under vacuum, it indicates the need for repairs or replacement of the brake booster vacuum hose to restore system integrity and ensure reliable braking performance. In the final troubleshooting step, it's essential to isolate the brake booster pressure sensor from the system. This involves installing a known good replacement sensor to determine if the initial failure can be reproduced. This step is crucial because the brake booster pressure sensor may not have a direct testing method. Thus, utilizing a verified sensor serves as an effective troubleshooting approach. If upon installation of the new sensor, the DTC disappears and normal functionality is regained, it confirms that the original brake booster pressure sensor was malfunctioning and needs replacement. Conversely, if the same symptoms and DTC persist, further investigation is warranted to examine other related components and connections. This systematic approach will ensure any fault is accurately identified and remedied. After performing all necessary repairs, it is crucial to confirm that the system is functioning as intended. This involves rechecking the DTC using the Honda Diagnostics System, HDS, to ensure that the DTC P15C7 is no longer present. If the DTC is clear and does not return during subsequent diagnostic checks, it indicates that the repair has been successful. Additionally, the system should be monitored during a test drive under appropriate conditions to validate the resolution of the issue. Clearing any stored DTCs is essential as it resets the system. Ultimately, ensuring that all components related to the brake booster pressure sensor are operating correctly will enhance the vehicle's safety and performance. Preventive maintenance is vital in ensuring the longevity and reliability of the vehicle's braking system, especially regarding components like the brake booster and its associated sensors. Regular inspections of the entire brake system should be performed to identify any signs of wear, leakages, or faulty connections. Special attention should be paid to the vacuum components, ensuring the hoses and check valves are free from damage and leaks. Prompt repairs of any identified issues can prevent more significant problems down the line, ultimately safeguarding the driver and passengers. By establishing a routine maintenance schedule that includes these steps, vehicle operators can maintain optimal braking performance and minimize the risk of encountering faults like DTC P15C7 in the future. In conclusion, addressing the DTC P15C7 involves a comprehensive understanding of the brake system components, including the brake booster pressure sensor, vacuum lines, and related mechanisms. Diagnosing this trouble code requires a structured approach, starting from basic inspections through to the use of advanced diagnostic tools like the HDS. Prioritizing safety and performance should always be the primary focus, as the braking system is crucial for vehicle operation. The symptoms and outlined troubleshooting steps serve as valuable guidance for technicians to efficiently identify and resolve the issue effectively. By using preventive maintenance principles, the potential for future DTC occurrences can be significantly reduced, thereby ensuring a safer driving experience for everyone on the road. Please like and subscribe to the channel. See you next time.